bit of topic 8.2 is circular motion. Uh, when referring to 8.2, we only look at uniform circular motion, which means that there's a constant angular velocity, and we'll get to what that means later. But circular motion just refers to the motion of an object about an axis of rotation, and as fairly self-explanatory in the name, it moves around in a circle, as you can see here in this diagram. There's a constant centripetal or net force. The net force is equal to the centripetal force, and the centripetal acceleration, which point towards the center of the circle that it's moving across. So as you can see here, the acceleration and the force are pointed towards the center. And there is a tangential velocity, and it's perpendicular to the centripetal force or acceleration. And it's, as you can see here, this is the velocity the tangential velocity vector. But you also have this new factor, which is the angular velocity, which same as velocity except in the rotational sense, which is how fast an object rotates. It's measured in radians per second and is expressed by the symbol omega. You have period t measured in seconds, which is referred to the time needed to complete one full rotation. And frequency measured in hertz is the number of rotations completed per second. As you can see here, there's an inverse relationship between frequency and period. F equals 1 over t, and t equals 1 over f. So they're reciprocals of each other. And here you can see that one of the formulas, v equals omega r, where omega is the angular velocity. And omega can be expressed as 2 pi over t, which is just, if you think about it, that's the same as velocity equals distance over time, because distance, I guess, in the angular sense is 2 pi radians, and the period is the time needed to make a full rotation. So yeah, it's just velocity equals distance over time. So you can rewrite this as v equals 2 pi r divided by t, so on and so forth. And you might remember from earlier in 8.2, the net force is equal to ma, the mass times acceleration. Well, here acceleration is equal to v, in circular motion, it's equal to the tangential velocity squared divided by the radius, the distance of the circular motion of the object from the center of the circle. And it can also be expressed as omega squared times r. And I forgot to mention it here, but r is just the distance from the center of the circle that it's moving in. Radius, as it implies. So you can rewrite F equals ma, and since a is equal to v squared over r, in circular motion, F, the centripetal force, is equal to mv squared over r. And that's basically it for circular motion. All you need to, what you might also need to do is remember the types of forces that cause the circular motion. It can be either an applied force or a gravitational force that contributes to the circular motion, a frictional force, so on and so forth. You'll need to be able to identify which force it is that's causing the circular motion.